So today we are going to start our discussion with harmonic oscillator and operator method. Okay, so we should say that quantum harmonic oscillator. Okay, a quantum harmonic oscillator. So okay, I'm not giving any introduction. I'm getting directly into the derivation part. That's how I have designed this video. Okay, let us write the Hamiltonian first. H is what? T plus V, where T is kinetic energy and V is potential energy. And kinetic energy we can write as half mv square, and potential energy for harmonic oscillator is what? Half kx square. So if you consider a spring mass system, k is what? K is the spring constant. So this is equivalent to that. Now what is k? Or can we replace k with something? Yeah, we know that omega is what? Omega is root k by m, or omega square is k by m, or we can write k as m omega square. Okay, now we can rewrite the potential as V is half m omega square k square. Okay, now we have both potential energy and kinetic energy, but kinetic energy we can also write as what? T is we sometimes we write it as p square by 2m. That's also fine, because how is that? Suppose v is mv. If you take v square, it will be m square v square by v square by 2m is what? M square v square by 2m, and m and this 1m will be cancelled, so we have half mv square. This is the kinetic energy. Okay, now how can we write the Hamiltonian now? Now Hamiltonian becomes h is equal to t plus v square by 2m plus half m omega square x square. Sorry, I have made a mistake here. Here we have written potential is half kx square, but here we have written k square. This should be x. Okay, so half m omega square x square. So now finally we can write the Hamiltonian as p square by 2m half m omega square x square. Okay, now this is our Hamiltonian. Now what can we do? Okay, so let us come to now we know that p, for momentum we have the operator p cap, and for position we have the operator x cap. Now we can rewrite our Hamiltonian. If you consider our Hamiltonian as an operator, we can write it in operator notation as p cap square by 2m plus half m omega square x cap square. Okay, now we are going to do something. Okay, you could say we are going to d-dimensionalize the equation. Okay, so what can we do for that? Okay, just follow the procedure, because I have already told you that I am just giving a step of or a combination of steps or series of steps that you can blindly follow and get the marks. That's all what I am doing here, nothing more, and I don't know more actually. So what can we do? What is d-dimensionalization? So you know that we sometimes write E as h nu, or what else? We write this is what nu is. No, sorry, what is nu? Nu is 1 by t, so we can write E as E is h into 1 by t. Now multiply and divide by 2 pi, so h by 2 pi is what? H cut, then 2 pi by t is omega, so we can write energy as h cross omega. So suppose we are able to write Hamiltonian as some h cross omega times something. Okay, but we know that since Hamiltonian has the dimension of energy, this h cross omega also have dimension of energy, then whatever it is here, this should be dimensionless. Okay, yeah, let's try what, let's see what we can do. So we are going to make two variables, also two quantities, which will be having dimension of momentum, let's call it p naught, and another one having dimension of position x naught. Okay, so to do that we are going to use uh, three variables or three constant which we have here, okay, namely h cut, m and omega. Okay, so we need, from these constants we need to make quantities p naught and x naught, where p naught is having dimension of momentum and x naught is having dimension of position. Okay, so let's see what is dimension of, let's take m first. What is dimension of mass? It is just m or m raised to 1. Now what is dimension of omega? Dimension of omega will be omega is 2 pi by t. Okay, so dimension of 2 pi by t, so 2 pi is angle, so it is dimensionless or a constant or number, so its dimension is just dimension of 1 by dimension of t. Okay, this is time period, and time period is time, so we use the symbol t itself, so you can say t raised to minus 1. So for omega we have t raised to minus 1. Now what is for h cut? Dimension of h cut is what? Okay, let's say we have energy is what? Energy is h cut omega. Okay, if energy is h cut omega, we know that h cut is e by omega. So the dimension of h cut will be dimension of e divided by dimension of omega. Now what is the dimension of e? What is dimension of e? Let's see, e is what? E is the work done, or work done is also having same dimension as energy. So let me tell you that dimension of e will be equivalent to dimension of work done, or which is equal to force into distance. Okay, call it s. Now what is dimension of force? Force is ma. So dimension of ma times dimension of distance. Now what is acceleration? For m we know the dimension will be m. What is for acceleration? Acceleration is velocity by time. Okay, and multiplied by dimension of distance. Now what is dimension of velocity? Velocity is what? Distance by time. So it has the dimension lt raised to minus 1. So velocity has the dimension lt raised to minus 1. Now when we have lt raised to minus 1 here, now we can write it m lt raised to minus 1 divided by t. T is having dimension t. Now multiplied by distance. This is a distance, right? Work done. So this will be having t. Now L. Now what will happen? Now we have t will go up and L will get multiplied. So m L square t raised to minus 2. This is what? This is dimension of energy. Okay. Now if you have dimension of energy, you know that dimension of h cross is dimension of energy divided by dimension of omega. Okay, but what is dimension of omega? We have already calculated that it was t raised to minus 1. If you can see, t raised to minus 1. So we can write dimension of energy as, dimension of h cut as m L square t raised to minus 2 divided by what was that? T raised to minus 1. Okay, now take the t upward, so it becomes plus 1. So 1 minus 2 will become minus 1. So the dimension becomes what? m L square t raised to minus 1. So we have dimension of h cut as m L square t raised to minus 1. Okay, now let me summarize what we have found now. So we have dimension of, what was that? Okay, we are looking at m, omega and h cut. Okay, from this we are going to make two variables x0 and p0, where x0 is having dimension of position and p0 is having dimension of momentum. Okay, so yeah, we have found that dimension of mass is m, then dimension of omega is p raised to minus 1, and dimension of h cut is, what was it, m l square t raised to minus 1. Is it? Yes, m l square t raised to minus 1. Now, yeah, now what do we need? We need something having dimension of position and something having dimension of momentum. Okay, look here, in this term, if we divide m and divide t raised to minus 1, we will get something having dimension l square. Then if we take root of that, we will get dimension of length, that's x0. Okay, so okay, so take h cut. Yeah, now we have m is having dimension m, so if you divide h cut by m, you will have something having dimension l square t raised to minus 1. Now if you divide it again by omega, you will have something having dimension l squared. So dimension of this quantity is l squared. Okay, so now we are ready to define x0. How can we define x0? Sorry, 1 second. How can we define x0? x0 can be root of h cut by m omega. Okay, so now we have x0. Now what could be p0? First of all, what is dimension of momentum? P is mv, so dimension of momentum is what? Dimension of velocity is distance by time, that is lt raised to minus 1. So we have m l t raised to minus 1. Okay, so we need m l t raised to minus 1 from these three quantities, m omega and h cut, and which is having dimension, h cut is having dimension m l square t raised to minus 1. Okay, now what if we multiply h cut with omega and m? If we multiply it with the m will become m square, then l square. If you multiply with omega, the t raised to minus 1 will become t raised to minus 2. Okay, so all the terms, all the m, l, t, all of them will have the power 2. Okay, now if you take root of that, we have m l t raised to minus 1. Okay, so see, if you take the quantity h cut multiplied by m and omega, this quantity is having dimension m square l square t raised to minus 2. Okay, now if you take root of that, we will get something having dimension of momentum. Okay, so we define p0 as root of, okay, instead of h cut m omega, let me call it m omega h cut. That is easy to read. Okay, now yeah, now we have, okay, now x0 and p0. Okay, now for no reason, or which will be clear later, or which you can see that was useful later, let me add a constant here which won't change the dimension. That is, let me call x0 as 2h cut by m omega, and p0 as root of 2m omega h cut. Okay, so now we have two quantities or two variables or two constants having dimension of a position and dimension of momentum. Okay, now what are we going to do now? We have the Hamiltonian, h cap is p cap square by 2m plus half m omega square s cap square. Okay, now now like I said before, let me take h cross omega out. That is, let me write it like h is equal to h cross omega times something. What would be that? Here in the first term, m omega will be downward in the numerator, so 2 m omega 2m, then h cross omega. or omega h cut plus here one omega is gone and one h cut is gone. H cut is gone from below, isn't it? Yeah, so we have to yeah, m omega by 2 h cut x cap square. Okay, so if you multiply h cut omega to inside, one omega will come, so omega square, h cut will be cancelled. Okay, so m omega square by 2 or half m omega square. Okay, that's it. Now what is 2m m omega h cut? This is p naught square, isn't it? Yeah, similarly what is here? This is what a m omega by 2 h cut, we can write it like 1 by 2 h cut by m omega. Okay, so in the numerator we have 2 h cut by m omega, which is square of x naught. Okay, so now we can write it like h cut omega times p cap square by p naught squared plus x cap squared by x naught squared. Okay, now look at this. So like I told earlier, this dimension of energy is lying within h cut omega, so all this quantity is dimensionless. Okay, will that be any useful? Okay, I don't know, this is just a way of doing it. I don't know how they came to this. I know, okay, I'm just giving you the steps. Okay, so finally we have Hamiltonian h cut is equal to p cap square by p naught square plus x cap square by x naught squared. That's it. And remember, what is x naught and what is p naught? X naught is root 2 h cut by m omega and p naught is root 2 m omega h cut. Okay, and now we have the Hamiltonian.